All right, so let's work with our next speaker. I think your presentation should be up in a minute. Our next presenter is Taeyoon Lee. He's a graduate student at Cornell School of Forestry here in UGA, and he's under the supervision of Dr. Bettinger. And is there presentation there? He's going to talk about the effects of nearby trees on GPS accuracy in forest environment. I think that microphone is on, right? So yeah, you can go with it.
Sorry. Okay. Good morning, everyone. First of all, thank you for having me here for the presentation today. And this is Taeyoon Lee, who is a PhD student at the University of Georgia. Today, I'd like to talk about the effect of nearby trees on the positional accuracy of the GNSS receiver in the forested area. The GNSS technology and receiver have been improved very rapidly in these days, and these are very commonly used in our lives. For example, you might already use the GNSS technology, which is implemented into your smartphone this morning to navigate the Athens. I mean, as like this, the GNSS technology and the receiver is considered as an essential element in the forestry field. For example, in the forest field, these technologies are used for the navigating the forestry inventory plots and delineating the boundary or the quantifying the effect of the productivity time logging of the logging equipment or the quantifying the soil impacts of the harvesting equipment. As the GNSS receiver, the antenna getting miniaturized, it can be implemented with various kinds of equipment, such as a smartwatch or smartphone or the tablets. So it might be a good replacement for the mapping grade receiver or the traditional receiver. So to do that, the study to investigate the positional accuracy of the non-traditional GPS receiver is necessary to implement to evaluate its applicability in the field. Furthermore, the forest area is considered the most challenging place for capturing the GPS signal, the satellite signals. There are many factors affecting the positional accuracy of the GPS receiver. Among those, the multipath error was considered the most influential factors, especially in the forested area. So a lot of study already done to investigate the positional accuracy of the GNSS receiver in forested area. Here is the summary of the previous study result. The positional accuracy of the GNSS receiver have a negatively proportional to the sand density. And the positional accuracy affected by the device. Oh, thank you so much. Very good. Yeah, the positional accuracy is affected by the device holding orientation and the number and geometry of the satellite, the available satellites. Regard to the time of year or the weather, the result is a little bit different depending on the study. Some study confirmed that GNSS accuracy was not varied by the time of year or the weather, but another study found the correlation between two, the significant correlation between two. So given this result, it's a little bit hard to generalize how the positional accuracy are changed in response to these kinds of factors. So these kinds of study utilize various types of GPS receiver to compare their positional accuracy between them, or to evaluate the applicability of lower grade GNSS receiver by comparing it to the higher grade receiver. Generally, the GNSS receiver classified into 3 categories, and there has a positive correlation between price and the accuracy. The survey grade receiver usually guarantee the highest positional accuracy, but it's very bulky and it's usually take a longer time to determine just one position. With this reason, the mapping grade receiver is the most common type in the field. But as I mentioned earlier, as the GNS technology getting improved, the recursion grade receiver have garnered its attention due to its price and its utility. So this study was conducted to evaluate the positional accuracy of a recursion grade receiver, including smartphone and Garmin receiver, and to investigate whether the inherent error, the positional error is systematic or random. With this reason, this aim, we set up the three hypotheses. The first hypothesis is the positional error of GNS receiver is not significantly different depending on type of GNS receiver. And the second is there is no correlation between positional error and forest variable, including tree count, average DBH, and location of nearby trees. The last one is these correlations are not different depending on the type of GNS receiver. In our study, we utilized two different types of GPS receiver. As a mapping grade receiver, we utilized the Trimble Juno T41, which allowed the user to change a lot of options, to change a lot of settings like PDOP value and signal to noise ratio and GPS augmentation or satellite system. And it equipped with a little larger size of antenna at the top of the receiver. Regard to the recreation grade receiver, we use the iPhone 12 Pro as a non-traditional receiver, and we use the Garmin receiver as a traditional handheld type of receiver. Both are equipped with a relatively small size antenna in it. And the Garmin receiver allows user to change a few settings like GPS augmentation or satellite system between GPS and GLONASS. Well, otherwise, iPhone did not allow user to change its settings, especially for the offsetting the satellite signals. Instead, it has 12 antennas in it. But I found that 2 of them are directly related to the offsetting the satellite system. One is in here, and the other one is here. It was not written, it was not documented in the manufacturer manuals, but it is believed to use the assisted GPS system to enhance its positional accuracy by utilizing the network resource from the cell phone tower in addition to the satellite signals. And according to the manufacturer manual, it can use the various kinds of satellite system, including GPS, GLONASS, Galileo, Beidou, or QGIS. This study was conducted at the Whitehall Forest GPS test site. There are 37 control points which were surveyed using the survey grade receiver with 2 centimeters of positional accuracy. We selected 2 of them, and then based on that, we cautiously set up 12 control points per each survey control points, as you can see here. And therefore, so we have a total 26 of control points, and then the control points depart from each other with 6 meters of distance. I visited 20 times during the leaf season, and then I used the monopod with the leveling device to place the receiver at the same position. Regard to the forest variables, we surveyed every tree within 20 meters of the radius from the surveyed control points, as you can see here. And then we cautiously measure the tree location and count every trees and measure the deviation of trees. So in this figure, the size of the blue circle represents the size of DVH. And then we calculate the average distance between control points and each trees within certain radius. So as you can see here, the average distance that did not represent any direction of the tree. Where the tree locates from the control point. So we added the average departure and average latitude of nearby trees. So for example, in this figure, these small trees have a positive latitude and negative departure. So these average variables are calculated as values within the from 1 to 8 meters from each control point. we use the RMS value, which is the root mean square error, because this is a very popular parameter to represent the positional error because it indicates the deviation from the truth without the truth. And we use the standard deviation analysis method. It is very useful method to representing how the observed points are distributed around the control points. So this method allows us the information about the central tendency and dispersion and directional trends of the observed points. So in here, the mean center can be calculated by the average of the latitude and departure, and it's represent the central tendency. And rotation represents the directional trends, and area and the perimeter of the ellipse represent how this dispersion of the observed point. Yeah, this is my result. The result about the Poisson error is much straightforward compared to the result of the correlation test. I mean, there is a significant difference between mapping grade receiver and regression grade receiver. But interestingly, the iPhone has a significantly lower Poisson error compared to the traditional receiver. Across the study site, the RMS value ranged from 2.28 meter to 9.77 meters. This is very relevant to other studies result. One more interesting point in here is that the standard deviation of RMS value for iPhone is very smaller than others. That's why they have a significant difference between two, because when you look at the data, it's very similar, but the standard deviation is very small. Regard to the parameter from the standard deviation analysis method, there is a significant difference between, but there is no significant difference between iPhone and trimble receiver in RSEM and area of the ellipse. In here, RSEM represents the root square error of the mean. The RSEM is another parameter to represent the positional error, but it considered about the direction of the error. I mean, because this parameter is closely related to the mean center. And regard to the rotation or the directional trends, they have no significant difference depending on the type of GNSS receiver. In here, the departure and latitudes represent the central tendency. For example, when the departure have a negative value, the mean center or the observed points are located on the west part of the control point. Otherwise, when it has a positive value, that means it has the mean center of the observed point are biased to the east side of the control point. When you look at this data, the mean center for observed points are biased to the south part of the control point because the value for the latitude are all negative, regardless of the genus type of receiver. Otherwise, the mean center for the Garmin and Trimble was biased to the west side of the control point. To visualize it, I select a few control points, and then in here, the red dots indicate the control points, and the little black X represents the mean center for latitude ellipse. You might not be able to see the red crossing here because those control points are right on the trees. Anyway, you can easily find the mean center are located on the south part from the control points. Here is the summary of the correlation coefficients. Please do not be overwhelmed by that number because there are too many numbers. In here, the important thing is that these correlation coefficients number represents they have a weak to moderate correlation between them. Some of them have a significant, and most of them have a negative correlation. Especially for the tree count and average distance of nearby trees, they have a negative correlation when the variable was determined within 5 to 8 meters, rather than 1 to 3 meters. Here's another summary for the correlation coefficients for the RSEM and the first variable. Very similar trend was observed. I mean, the correlation, the only weak to moderate correlation was found, and then very few are significant. And especially for the tree count and average latitude of nearby trees, they have a negative correlation regardless of the genus receiver type. Here's my conclusion. The positional accuracy of regression grade receiver was significantly lower than the positional accuracy of mapping grade receiver. However, when the positional accuracy evaluated by the RSEM, which with the consideration of the direction, there was no significant difference between iPhone and the trimble receiver. That means iPhone might be a good replacement for the expensive mapping grade receiver. Regard to the correlation between positional error and the forest variable, the weak to moderate negative correlation was found regardless of the genus receiver type, but I think it's too weak to interpret it has a correlation between them. So in further study, I'd like to develop another new forest variable which might have a moderate or strong correlation. And then I'd like to investigate the correlation between forest variable and the directional distribution of observed point, such as mean center or area of ellipse. Thank you. Do you have any questions or suggestions for my study?